Welcome to TopSolid 7. In this video, we're going to talk about machining a timing screw. In some of my past blog posts, I've shown you how quickly and easily you can create a timing screw thanks to the powerful tools available within the TopSolid suite of design. In this video, we're going to show you that we have your back covered even on the manufacturing side. At TopSolid, it is a core concept that if we give you a way to design something, we also have to give you a way to manufacture whatever that something is. Timing screws are no different. They're very complex pieces of geometry, true, but thanks to TopSolid, maybe they're not so complex after all. Here's how timing screw manufacturing works. In TopSolid, we have a specific function here under our 4 and 5 axis tab called screw milling. Let's start with this. With screw milling, the first thing I need to do is pick a tool. So here I'm going to use a 3/4 inch end mill to do my roughing with. Next, what I want to do is define the geometry that I want to machine between, and it's really simple. I'm going to machine between this edge and this edge. Give it a second, and you'll see a preview pop up, and this preview is just showing you kind of some cross sections of the area to which we're going to machine. From here, we're going to set up the machining itself. For example, I'm going to do this at about an 8/10 tolerance, and I want to leave maybe 20 thousandths of stock. As far as our Z step, I want this to be an 1/8 inch step in Z. As far as my step over is concerned, I want this to be maybe 300 thousandths. For my strategy, we have a lot of cool choices as well. Here, what I want to do is use alternated displacement, and all this means is that we're going to machine via climb cutting up one side of the tooth and then switch to the other side of the tooth and climb cut back down. So we're always winding and unwinding, winding and unwinding the machining of this screw. That's all we need. Let's click OK. Now, another thing I want you to pay attention to during this video is the fact that I'm recording this video and doing this video as I'm speaking. And the reason I like to do it this way is because then you can see just how fast TopSolid is. In fact, it's done already. Check it out. We're going into the machine simulation now. And now we're seeing the tool do what the tool does. It's going to machine this part. Fantastic. Let's escape out of the simulation, have a quick look at that toolpath. That toolpath is actually pretty cool. If we look, there's everything. And it did it in seconds, not hours of calculations. Next, I want to finish this. Well, thankfully, our screw milling function offers a finishing cycle as well. Let's give it a shot. All I'm going to do next is I'm going to come into here, go to my kind of machining and say, you know what? I'd like to go to finishing. Fantastic. Of course, I want to change my tool because I don't want to finish with an end mill. I want to finish with a ball nose mill. So there's my ball nose mill. It'll be a 1/2 inch ball mill. And from here, what I want to do, again, go into my settings. Maybe the only thing I want to do, say I want to go to finish. And as far as my step over, I'm going to say, how about something like a 50,000 step over? That's about a 2,500 scallop, which for our example today will be just fine. Again, watch the speed of TopSolid. Thanks to our 64-bit multi-core engine, you can calculate faster than you ever thought possible before. The computer I'm running, for example, has a Xeon processor in it. It has a lot of memory in it. It's running on Windows 10. We're taking advantage of everything out there that hardware brings to the table. Look at that. Super, super fast, super, super smooth toolpath. Now, let's watch the simulation on this because again, it's important to see what's going to happen, and that's one of the great powers behind TopSolid. You always get to see. So here, we've led on, and now we're climb cutting down the tooth, and now watch what happens. It's going to walk over to the other side and climb cut back. Now, one of the things that maybe I don't like about this tool path is we're starting with the tool on top of the tooth. So we're only cutting a little bit, and I think it'd be more interesting if we could shift the tool to start more inside the tooth. And again, you can do that, and you can do that because it's TopSolid. Here's how that works. What I'm going to do next is go to a command here we call isoparametric curve on parallel. This command allows you to create a curve based on the ISO-U or ISO-V, which is the kind of the spine of the surface, based on a rotation axis, based on a tool size. So tool diameter 1/2 inch, corner radius 1/4 inch. So yes, a bullnose cutter could be calculated as well. And what these curves are calculating are a shift for us to start the tool path further in on both sides of the tooth. Now, because TopSolid is trying to make things easy for you, we extend these curves way past what you need. So we need to trim those back a little bit. How do you do that? Simple. Let's go to trimming. I want to trim, for example, this curve to this planar face. Boom, there's your preview in orange. I'll click OK. This curve to this planar face. And yes, I'm working with really, really complex curves in three-dimensional space without having to fight with my software. And think about that too. I mean, everything I'm doing in this sample, I'm doing with ridiculous speed. And that's the point. We want you just to be able to focus on getting your job done quickly and efficiently. So again, this is what that finishing toolpath looks like now. What I'm hoping to do is optimize the toolpath a little bit so that I get to cutting and finishing that much more quickly. So to do that, all I have to do is change my curves. And I apologize. I made a mistake. Mistakes happen. I have to put my curves before the machining task in history. Since we're a parametric software, things have to be done in order. Makes sense. So I'm going to go back and edit this now, and let's go edit our boundary curve. So we'll come in here now, go to geometry. I'm going to delete this one, and I'm going to say, actually I'll delete them both really quick. Then I'm going to say I want to use this profile for the first curve, this profile for the second curve. There's your preview. We'll click OK, and our toolpath will come away. And here in a second, you'll see these starting curves on both sides, or the starting paths on both sides, kind of shift inward a little bit because, again, the whole idea is to get the side of that ball cutting the side of our tooth as quickly as possible. There you can see the preview of the toolpath. We've trimmed away a bunch. And if I watch the simulation now, let's see what happens. So now if I pause this and we rotate this around, you can see that the side of the ball is now in contact with the face more directly. Let's let this go through to the other side, and we'll pause it again on the way back, because then you can get a really good look at it. Perfect. So now we're cutting with the side of the ball inside here. And again, thanks to the speed and power of TopSolid, this complicated task wasn't so complicated. In fact, we did this all within about 7 or 8 minutes of time. Fantastic. Thanks for watching. Check back soon for more cool TopSolid tips and tricks.